tunnel design and construction is full of challenges that requires experienced professionals and engineers. During the last 50 years, geotechnical engineering has been incredibly developed, but still there is room for improvement and automation. For example, convergence measurements during tunnel construction is still quite labor-intensive. The digitalization and automation of this task is one of the objectives of the new digital mETABUILDING system, developed by a partnership of 3 companies: Geocontrol, Tailored Systems, and DFM Europe. Each one provides a specific added value to this project. The digital mETABUILDING platform aims to provide a cost-efficient solution for measuring convergences inside of a tunnel, with easy installation and low maintenance needs. It ensures the continuous and automated monitoring of the tunnel and wirelessly transmitting data in an autonomous mode. To better understand it, let's first explain how tunnel excavation is normally monitored. During the excavation of any underground structure, the stress balance in the ground is modified. This reorganization of forces around the excavation induces a certain degree of deformation at the perimeter of the excavation, which depends on the geomechanical parameters of the ground. Traditionally, this deformation, called convergence, is measured in situ by measuring the relative distance between 2 reference points on the perimeter of an excavation. This is the most effective method for monitoring the stability of the tunnel and is very important for characterizing and predicting the behavior of the excavation, as well as for evaluating the adequacy of the parameters used in the design calculations. In the traditional method of convergence measurement, the person taking the measurements uses an extensometer, takes the data on a paper template, and then types the measurements into a spreadsheet, containing 1 sheet per convergence station. However, this manual methodology is subject to human error and is time-consuming. In addition, this measurement system interferes with tunnel excavation activities, and when tunnels are in service, the measurements cause service interruptions and have to be carried out at very specific times, usually at night, and under the strict supervision of the owner. To avoid these inconveniences and ensure fast and efficient management of convergence measurements, the new mETABUILDING system is a tool designed to measure, store, and manage convergence measurements in real time, thus enabling the technical team to anticipate tunnel construction problems. The mETABUILDING system, taking advantage of the latest technologies, performs convergence measurements using precise laser distance meters, allowing several measurements to be taken per day without affecting tunnel activities. This is particularly important when it comes to measuring convergences inside of underground structures in service, with road or rail traffic. mETABUILDING also applies new Internet of Things technologies and state-of-the-art software development. The measurements recorded by the laser distance meters are sent to a LoRaWAN gateway, a physical device that hosts both the hardware and the firmware used to connect the laser devices to a web server in the cloud. LoRaWAN is a connectivity protocol known for its low power consumption and long transmission range. It is also highly resistant to interference, as it is based on military and space technology. The gateway then converts the readings into a signal compatible with the web server. From there, the mETABUILDING system stores all readings and manages them in real time. The end user can then obtain all this information and process it to understand what is happening in the tunnel. During the design development phase, the team identified the specifications of the devices to be procured. Once obtained, they were tested and calibrated in the laboratory. Once the lab testing was completed, the team was able to run the system on a real project, as Geocontrol participates in the construction supervision of some of the longest high-speed railway tunnels being currently built in Spain, in Pajares, Asturias. 4 laser meters were installed in the Pontones tunnel as well as a LoRaWAN gateway. 2 of these laser devices had a 1 mm accuracy and the other 2 0.1 mm accuracy. Once the installation was completed, the entire system was checked to ensure that it worked by means of a platform that verifies the system status. After completing all the development phases of the product, The MECADI system is now working properly, although there are still some issues to be solved. It has been found to be sensitive to network coverage, so there are periods when there are no records. Further research is needed to confirm that the reading interruptions were due to the lack of internet coverage. Also, the weatherproofing and finishings of the laser devices need to be improved.
CEO of Metrica 6, and we are the leaders in the consortium for the metabuilding project called Natural DigiBuilding. What we did during this project is that we created several devices and a platform to control these devices and to check how they perform. And those devices are set for having a measurement of how a new refurbishment is efficient regarding the energy efficiency and the energy consumption, and also the water consumption. So what we did was to create this set of devices and platform, like for example this one that I show you here. This is, well, this one is open. This is for the air quality monitoring outdoors and indoors. As you can see, it works with batteries, Another one of the devices that we have developed here, this one, which I took the electric board, but this one is for the water management or the water control. So here you can see part of the system, which is a valve with with a set of sensors for water flow and for water temperature. And what we did was to communicate all these sensors and all these technologies, which we also researched during the program, and we communicated them with a platform that we also developed during this project. So by the end, what we have is this ecosystem of devices and web app, which is the software part, a web app, and you can check there how all these sensors perform in your installation. So you can have a digital twin of your installation, and very focused on the part of the energy efficiency and water usage efficiency. So how these measurements can help you to know more about your installation and how you can improve your efficiency and to have a more sustainable or responsible consumption. So that's the main point of what we did in this project. And now it is up or next to the commercial stage. And what we are doing now is to create this web for promoting the devices, to check with different partners and investors for different smart city projects, and of course private projects related to the smart city, smart home, sustainable construction environment. So if you want to help us, you can already check in our website. You can check for Ysense, which is the name of the water solutions, and you can check also for iMind, which is the other part of the solutions for the air quality control, the temperature, etc. And they work under the same environment that we have already created. So thank you, MetaBuilding, for granting us the opportunity to create this project, to learn so much about how to perform this kind of solutions. You also granted us the opportunity to create this collaboration with a transnational or international company, which is Integrated Worlds. They are from Germany, but they work in other countries as well. It has been a really great opportunity for us to create this kind of collaboration, because we know that it's not going to be the last project that we collaborate in. In fact, they have the chance and they have the opportunity to work with us in other Spanish projects, and now we have the opportunity to work with them in other German projects regarding this technology. So thank you very much for your time. Thank you everyone, and enjoy looking at the devices and what we do in our website, and hope to know more about you soon. Thank you very much.
Hello, I'm Fernando Morales, CEO of Being System Company. We are presenting Wellbeing Project. The main goal of Wellbeing is to demonstrate the use of digital twins to improve the comfort and indoor air quality of buildings, bringing to users valuable information. The project consists of obtaining measurements of CO2 and other pollutants in the air and ambient data such as temperature, humidity, as well as the automatic detection of people in the room, crossing the data with the BIM model as a reference in order to analyze all the information in real time, and being notified if the values are on warning, and we need to open windows to improve the indoor air quality air index. Our Wing digital twin platform integrated to IoT technology is the key factor in Wellbeing project. These technologies are the ones we propose to improve interior conditions in the spaces we live and we work in the 90% of time for people living in cities.